Over the years, I've spoken quite a bit about flash powders, but this one is specifically about making colored flash powders, and I'm going to focus on red, green, and blue. Some info about this, especially history. The first flash powder is attributed to using lycopodium powder, and it is the genus Lycopodium. There are other species. It's the fine powder that comes from the dry spores of the club moss plant. There are other plants that also do this, and they are highly flammable. There are quite a few demonstrations of burning lycopodium powder online. If you look for them, I'm sure you'll find them. Today, the most common flash powder is potassium perchlorate and aluminum in a 70-30 ratio. Before that, potassium chlorate was used, but of course, potassium chlorate can form some unstable mixtures, especially with metals. However, I'll go over the reaction real quick. It's potassium chlorate, 2 aluminums yields aluminum oxide, and potassium chloride. A quick comment on aluminum here. You'll find out that when I go over the colored flash powders, aluminum is not used at all. The aluminum oxide that is produced in most reactions that involve flash powders is then secondarily burned, usually breaking up the oxygens in the aluminum, and it produces a very white, very bright light, and that's why it's typically not used with colored flash powders, because it kind of blinds the rest of the coloring. Colored flash powders still require the standard oxidizer plus varying metal nitrates that create those colors. Strontium tends to produce red, barium a blue-green, sodium a yellow, lithium a crimson red, calcium orange red, and copper a green-blue. These metals, of course, never occur pure, say as a powder, but they're often mixed with something else like strontium nitrate or barium nitrate. But when they burn, it is the color of the metals within those compounds that really brings out these colors. For the best color, you really need a chlorine donator. Chlorine combines with the metals instead of oxygen, and that emits a narrower, more intense color emission line. So I drew this little thing here to explain this better, I hope. On the y-axis, we have the intensity or brightness of the light, and down here we have in nanometers the frequency of the light. So red is right around 660 nanometers. When strontium burns, as an example, it becomes strontium oxide, and strontium oxide emits a very shallow band of reddish light, which covers other nanometers in light, which aren't just bright red. So it's kind of a dulled red. When strontium burns with chlorine, from a chlorine donator, it produces a very sharp curve right around 660, which is where red is, and you can obviously see that much, much better than you can with just a strontium oxide. A couple examples of chlorine donators are Parlon, which is basically chlorinated rubber. It has about a 65% chlorine content, and PVC, and of course polyvinyl chloride. You have chlorine in there, which has approximately a 55% chlorine content. So the PVC is not bad if you buy it. It's really a much lower content than if you specifically buy the type of PVC that's made for either fireworks or flash powder, where you get a much higher chlorine content. I have Parlon right here, and you can kind of see it a little bit, maybe. Yeah, you can. It's just this very light powder. It reminded me of powdered sugar, to be honest with you, but that's what Parlon is. The other decent chlorine donators are oxidizers. This one is ammonium perchlorate, but potassium perchlorate also works. So you need an oxidizer. Those two are some of the best to use when you're making a colored flash powder. And just like colored smoke bombs, we really need to try to keep the temperature down here. If it gets too high, everything burns a bright yellow or white, and you don't see anything. One of the best things for this is dried shellac, believe it or not. And shellac comes from a bug. It comes from the female bug, Curia laca, that eats things, and then through a tube, it actually excretes shellac, and that's scraped off of the tree bark. That's how we get shellac. It usually comes in flakes, but I needed to grind mine to a powder. I'll show you that later, actually. The other ones are Parlon, which is not only a chlorine donator, but it also slows the burn rate down. And the other one is lactose. So these are sort of odd things that you wouldn't think you're going to add to a flash powder, but it does lower the temperature and brings out the color. The other thing that happens is they tend not to go off with a report. They burn a little slower, not fast enough to give you a report, but the colors, well, they speak for themselves. In our materials, I only mentioned a few here. Potassium perchlorate, potassium chlorate, which I actually won't be using, ammonium perchlorate, strontium nitrate, barium nitrate, copper oxide, magnesium. Again, why we use magnesium instead of aluminum, I mentioned earlier, Parlon, shellac. I also came up with, I think there are 6 or 7 more things that are involved in making 6 different mixes. 2 of them will be red, 2 will be green, and 2 will be blue, but to achieve those requires quite a few different ingredients. In our methods, we are going to weigh X, Y, and Z, and A, B, and C if necessary. We're going to gently mix these because you can't grind them, of course. We're going to place a fuse in there, light the fuse, and enjoy the colored flash produced by burning X, Y, Z, and possibly A, B, C. And obviously X, Y, Z, A, B, C are the different things we'll be mixing to come up with these colors. So enough talking about this again. Let's go ahead and make our colored flash powder. Before we go any further, I just want to show you the notepad here that I used when I was working through this particular project. So I started with the reds and did several of those and got decent results pretty easily, actually. And then I got into the greens, and those weren't that difficult either. But I still tested, I don't know, maybe 8 of them or so. And then I got into the blues, and that's really where things got tough. And I kept testing and testing. I got several pages of blues here. I did a total of 27 tests, and that includes red, greens, and blues. I chose in the end 2 out of each category, the best, 2 reds, 2 blues, and 2 greens. You saw the shorter list earlier that I was mentioning, but here are 15 of the chemicals and compounds that I used to come up with the 2 best, red, greens, and blues, and these will be the ones that I'll be drawing from as we work through this. One of the more unusual things that I'll be using is shellac, and these are shellac flakes, which I bought on Amazon, but most music stores carry this stuff, and but they also have it in a stick form. But yeah, like you can crunch this stuff forever. It's kind of satisfying. But what I did was take those flakes, put it in a coffee grinder, and ground them to a very fine powder, which you can see in here. It's almost white now. But anyways, yeah, that worked really well. To start off, the first red is going to be ammonium perchlorate, 6.5 grams, strontium nitrate, 4.6, shellac, 2 grams, and magnesium, 2.6 grams. These are the corresponding percentages of these, just in case you want to do it with different amounts. 6.5 grams of ammonium perchlorate, pre-weighed. 4.6 grams of strontium nitrate, pre-weighed. 2 grams of powdered shellac flakes, pre-weighed. 2.6 grams of powdered magnesium, pre-weighed. Now I'm just going to pour all these, of course, into one plastic beaker. So I ground all these to a powder before I put them in their individual containers that I'm drawing from to weigh them. So everything's already powdered as much as possible, so all I need to do now is mix things really well. Now you can see that mixed. I have these metal cups right here that I've used in the past. I'm just going to dump the powdered mix in here now and place a fuse, and we're going to light it. For the next performance of red, we have strontium nitrate, 4.5 grams, magnesium, 4.5 grams, and Parlon, 0.75 grams. And again, the percentages. 4.5 grams of strontium nitrate, pre-weighed. 4.5 grams of powdered magnesium, pre-weighed. 3/4 of a gram of Parlon, pre-weighed. There you can see it mixed. Pour. Switching colors to green, and this one's relatively well known. Zinc 12 grams, sulfur 4 grams, and Parlon 3 grams. 12 grams of powdered zinc, pre-weighed. 4 grams of sulfur, pre-weighed. 3 grams of Parlon, pre-weighed. Figured I'd mix them right in the metal cup. Saves me a step. Here you go, last one, or first one I should say, for green. Every time I come out here to do another one, the temperature keeps dropping. It's like 16 degrees right now. For the next green, we're going to use potassium perchlorate, 5.6 grams, barium nitrate, 2.7 grams, and homemade dark aluminum, 4.7 grams. And again, the percentages. 5.6 grams of potassium perchlorate, pre-weighed. 2.7 grams of barium nitrate, pre-weighed. 4.7 grams of dark aluminum, pre-weighed. There it is mixed. Obviously, some of the dark aluminum splashed out. I'll gather that and put it in here and remix it off camera. Oh, I hope the camera picked that up. That's a beautiful green. On to the terrible twos, blues. These were by far, as I said, the most difficult, but I think these will be pretty effective. So we have ammonium perchlorate, 8.1 grams, copper carbonate, 1.4 grams, hexamine, 2.1 grams, and dextrin, 0.45 grams. Now, typically dextrin is added to stars in order to compact and hold things together after you wet them, but in this situation, it's just being used to slow down the burn rate. 8.1 grams of ammonium perchlorate, pre-weighed. 1.4 grams of copper carbonate, pre-weighed. 2.1 grams of hexamine, pre-weighed. 0.45 grams of dextrin, pre-weighed. All right, well, there you go. For the second blue here, we have the most number of components of any of these that I've tried. Potassium perchlorate, 8.1 grams, lactose, 2.4 grams, Parlon, 1.3 grams, copper oxide, 1.2 grams, and sulfur, 0.4 grams. 8.1 grams of potassium perchlorate, pre-weighed. 2.4 grams of lactose, pre-weighed. 1.3 grams of Parlon, pre-weighed. 1.2 grams of copper oxide, pre-weighed. 0.4 grams of sulfur, you got it, pre-weighed. There you go.